Okay, this is the last video for chapter 11, section 2. We're going to talk about the area of a sector. So that's basically the whole slice of pizza, not just the crust. That would be your arc length. We are going to use fractions, so let's get comfortable with that. In fact, we're going to use a similar method that we did to talk about arc length. So we are on page 604. You're with me. I'm going to do 5, 6, and then 605, 7, and 8. We're drawing this time. So let's look at the core concept at the top of the page. Remember when we did arc length and how to find the actual length of the arc, since we talked about degrees before? We're going to do something similar with the area of a sector. We're going to have two fractions. Okay, again, this is the core concept of page 604. All right, so we have a whole circle, draw with me, right? And we have a slice taken out, right? And it's a central angle, okay? So here we have an angle, and I'm just gonna give it some random degrees. Okay, so this angle of 50 degrees is a part of the whole circle, right? So the measure of that angle, the part of the angle, the part of the circle, compared to 360 is going to be the same as, is going to be proportional with the area of the sector, and the book names the sector APB, the area of the sector that has that angle compared to the whole area of the circle. So the part of the angles to the whole kit and caboodle, 360, all the angles, is going to be equal to the area of the sector divided by the whole circle, the area of the circle. That's where we're getting pi r squared from. Remember, part over whole degrees, now it's part over whole area, okay? So let's skip down. You have example 3 you can look at. We're going to skip down to number 5. At the bottom of the page, looks like 5 and 6 talk about the same circle. So why don't we draw it? We have a circle. Not a very good circle this time, but that's okay. The center is D. Here's a point F from the radius of 14 feet. Here's a point E. Here's a little point G, another radius. This is 120 degrees. The smaller part of the circle is in red. The larger part of the circle is in blue. If you need to keep drawing, you can go ahead and pause until you're done and then move on with me. But I'm not going to pause. So number 5 says, let's find the area of the red sector. Okay, so, what's my degrees for the central angle of the red sector? In fact, let's do it in red. It's 120. What is the measure of the entire circle in degrees? It's 360. Okay, we want to find the area of the red sector, so I'm looking for that to be my variable, this part. Oops, that should be in red. Best laid plans. Now, what is the area of my whole circle? Well, if my radius is 14, so what's pi times 14 squared? Do you know what 14 squared is off the top of your head? If not, you have that. 196 pi. Do we know the units? Yes, we do. 8 squared. Okay, part, whole, part. That's what I'm looking for. Whole circle. Degree over degree cancels out. 0 over 0 cancels out. 12 goes into 36 3 times. It's kind of nice to actually be able to simplify your fractions. If you didn't simplify your fractions, did you get the wrong answer? I hope you said no, but it's sometimes more confusing. How am I going to get this variable by itself? Well, I'm going to take this entire denominator, and I'm going to multiply it over here. So I have 196 pi square feet all over 3. Do you know how many times 3 goes into 196? Yeah, me neither. Sure, we could figure it out, but that's what we have this for. I wasn't going to guess that, was I? And I could times it by pi. Now, I kind of did a little weird. You know, you can do it this way. I wanted to see if I was going to get a nice number. But We could also just say 196 pi divided by 3 because 3 is the only thing in the denominator. Math makes sense. We're going to round to the nearest hundred, and we're not going to forget our units. So 205.25 square feet, approximately. And that is my area of the sector. You know what? Let's actually, this is the whole circle. Do you expect this 196 pi to be greater than or less than the value of 205.25, right? 196 pi is, okay, good. It is, I'm sorry, it is bigger, of course. We divided it by 3 to get a number, so this times 3 should be that. I wonder, that might actually help you figure out how to do the next part without using the new math, but I want to use the new math because we're learning, so we have to practice. Find the area of the blue sector. All right, well, if this was 120 degrees, what's this angle? It's got to be 360, take away 220, which is 120, which is 240. 240 over the whole circle is equal to the part over the part. Sorry, I'm trying to get the circle in with the variable. So part over whole, part area over, we know what the whole area is. It is, oh, again, I did not color code correctly. Sorry, kids, you're going to have to bear with me. You know I make mistakes. All right, oh, there's supposed to be a degree here, so the degrees cancel out. Remember, we're talking about area, so we should have degrees in our answer. Zeros can cancel out. 12 goes into 24 2 times. 12 goes into 36 3 times. How we're going to get x by itself, we're going to take that and we're going to multiply it over here. Of course, we're multiplying to both sides. 196 pi feet squared over, and we're canceling out for my YouTube viewers that are not going to see me in person. But we are in geometry, which means we can start taking some careful shortcuts. So I have 2/3 over here. I'm multiplying it with 196 pi feet squared. We know that this doesn't go in evenly. We know we can just turn to our calculator. Of course, I could go back up here and times by 2. Don't tell anyone. Pi times 2 over 3. I get 410.50, 410.5-ish square feet. Okay. And hopefully this plus this, sorry, you can't see, this plus this would equal the whole circle. And if we look up here, you know, 205 plus 410, I hope you can do it in your head, is about 615.75. So remember, if you're finding the area of a sector, we're going to have a part over whole degree fraction, and we're going to have a part over whole area of the circle fraction. The part would be the sector, the whole would be pi r squared. Let's see if we can apply some of this. Let's take a look at number 7 on page 605. We want to find the entire area of circle H, and they just give us, draw with me now, ladies and gentlemen. They give us this information. G, it looks like the area of the sector is 214.37 centimeters cubed, and the degree is 85 degrees. I'm just going to color code it in a little bit. You should be doing that with me as well, just so we don't get lost if we forget what we're doing at the end of this problem. Okay, now let's start filling in our fractions. Okay, we're looking for the area of something, so fraction equals fraction. Okay, let's do part over whole degrees. Part over whole. Now that's equal to, I know the area of my sector. What was it, centimeters squared? I have bad handwriting, as you know. And so now I'm looking for the area of the circle, so part over whole. So 85 degrees is to 360, as the area of the red sector is to the whole circle. My variable's down here, so maybe the simplest thing to do is cross multiply. Oh wait, let's actually simplify. The degrees cancel out, so I don't need to bring them with me. But I do have 85a equals 360 times 214.37 centimeters squared. How am I going to get A by itself, I'm going to divide by 85 to both sides. And notice my only unit is square centimeters, which would be an area unit. So I'm on the right track. 360 in our calculator times 214.37 divided by 85. We should get about 907.92 centimeters squared. Okay, so we found the whole area, part over whole degrees, part over whole area. All right, what about this weird little figure for number 8? They give us, oh, well, they just give us a triangle with a semicircle attached to it. Maybe like you went to the ice cream store and they gave you a deformed cone. All right, we want to find the area of the whole figure, so we're looking for the area. Well, how about we start with the triangle? So we're going to do the area of the triangle plus the area of the semicircle. Look at my notations. Area of the triangle plus area of the semicircle. Well, area of the triangle would be half the base times the height. Well, this is the hypotenuse, so base and height. So how about half 7 times 7? How about half of 49 plus? All right, well, wait. What's the, what is this shape? Is it a, what type of sector is this? A semicircle, right? It's half of a circle. So plus half pi r squared. All right, well, half pi, except what's my radius though? My diameter is 7. What's half of 7? It's 3.5. And we're going to square it. So 7 times 7, base times height, half the base times the height, half of 49, plus half, 1/2 the area of the circle, because it's half a circle right here. Half pi, 3.5 is the radius, 3.5 squared. I don't know what 3.5 squared is. So I'm just going to go in here. I'm going to do 0.5 for half. So oopsies, half of 49 plus half times pi times 3.5 squared. Now I can type it in like that because the squared is only going to the 3.5 order of operations. And so we get about 43.74. We got to do it right. Square meters. I was pointing to these square meters. Okay. So those are just 2 examples of different ways of doing problems and breaking things down to solve a weird looking figure. Okay, that's it for chapter 9. Oh my God, I keep saying that. Chapter 11, section 2. It must be the heat. I apologize. That's it for chapter 11, section 2. You're going to have practice problems. Make sure you take notes on things that you're stuck on so we can discuss them when we get together.